Hi, this is David Case from Fix Gaming, and I wanted to start a little video series talking through kind of where we've been as a company, what technologies we've researched, and kind of to present to kind of where we're at right now, and hopefully just share share some information with everyone, and hopefully start opening up more into kind of the tech we're working on and making some of that open source and putting it out there for other people to use. So I wanted to start with just kind of giving a background of us. We started in, I want to say it was very early in the beginning, actually, right at the beginning of 2018. This was right after there was the CryptoKitties craze on the Ethereum chain, and people started kind of initially looking into the idea of gaming on blockchain. We at Fix spent a good, well, we weren't Fix yet then, but sorry for the dogs in the background there enjoying showing off. We started building with very simple concepts of just Ethereum smart contracts, which were starting to build out the concept that is now crypto fights. And so in that idea, you would have a fighter that was an NFT that existed on Ethereum. And maybe you'd have some weapons that were on Ethereum as well. And essentially, you would commit yourself to a battle, which is really just making a transaction that states that you own these fighters and items and you're configuring them in a certain way that you want to fight with someone else. And the idea at the time was very simple. One user puts in their fighter, another user puts in their fighter, and the system matches them and determines a winner based on playing through a series of events. It didn't take long at all before we came to the conclusion that Ethereum just really couldn't scale. That essentially, even doing fairly simplistic logic within our battles quickly got us to the point where we were taking up the entire gas allotment of an Ethereum block. And so at that point, we started really digging into alternative ways that we could have a blockchain game where the events are provable, the ownership is provable, and rewards are auditable. So we started looking into, at the time, a lot of different side chains and second layer stuff. And that was real big in Ethereum at the time. I don't even know if I can remember the names of the different technologies they were using. But there was a lot of stuff that was looking into kind of having second layer chains which would commit to the main chain kind of checkpoints. As we started building that out, we built on the Loom chain, which was an Ethereum virtual machine chain that used, I think, a proof of authority or maybe a distributed proof of stake. I think it was a proof of authority. I don't really remember. Consensus mechanism to run EVM contracts on a side chain, basically. And so we spent about a year working on pretty much all of 2018, working on a solution to put crypto fights in essentially a playable form. That process was great learning experience, but proved to be fairly fruitful. At the end of that year, end of 2018, is when the Bitcoin Cash BSV hash war happened. And before that, I had never really understood the concepts of Bitcoin as a development platform. It was very esoteric, where in Ethereum, it's essentially a standard programming model. Where if you're a programmer, you can write a code that runs on Ethereum just fine. Bitcoin complicates that, but it also gives a lot more power. So in an Ethereum virtual machine, every function that's called, every transaction that's made updates a global state. So they've got this one global bucket of state for everything that exists on the Ethereum chain. And so transactions are processed one after another, and each one updates that global state. So what this means from the standpoint of someone trying to develop on that is there is no concurrency at all. And in fact, not even is there no concurrency, but a single user making transactions are forced to linearly sign off on each of their transactions with a sequential nonce. So if I make transaction 1, and then I make transaction 2, and then I make transaction 3, well, transaction 2 and 3 cannot get on the chain until transaction 1 has gotten onto the chain. And so what this really means is as you start trying to update multiple things at a time, first of all, the nodes simply cannot process that much information. Everything globally on Ethereum or an Ethereum virtual machine based chain has to be sequential, has to be single threaded, which means no matter how much you scale up resources, your max throughput is going to be what a single thread of a CPU can handle at a time, can calculate at a time. And there's a lot of different approaches to sharding that out and different concepts around scaling, but ultimately it comes down to the concept that says at whatever division we've got of a shard or the whole chain, you still have a global state, and that state changes one transaction at a time. And so you still end up with a ultimately single-threaded solution. So back to this Bitcoin hash war happened. And that started setting, I guess in my mind, started making me start digging into what really makes up a Bitcoin transaction. What can we do with a Bitcoin transaction? And instead of the Ethereum model, it's like, okay, any programmer just grab this code, write this code, compile it, and it's good to go. Bitcoin is far more flexible, shall we say, in that at the base layer, what you have are UTXOs. And UTXOs are transaction outputs. But to move that state from a previous state that it was to a new state is all done by validating the script of the spends of these transaction outputs. And so what that means is essentially you can, from a mining standpoint, process not one transaction to update the global state, but essentially every UTXO has its own state. And so for validating the chain, unless there is overlaps or unless there's connections between those UTXOs, you can process them entirely. Every transaction can be processed in its own thread simultaneously. Which, when looking at developing software on top of that, really, really opens up the kind of the floodgates of what you can do. So we, back again in, I guess at this point in early 2019, we really started looking at taking CryptoPhytes from what we were building on Ethereum and second layer EVM chains and kind of flipping that on its head and building that on top of Bitcoin SV. SV simply because it is the only Bitcoin proof of work public blockchain that actually has an interest in scaling to very, very large volumes. And we'll get to that later about why that scaling really matters and what's important about that concept. And how Bitcoin and proof of work really bring that together to provide the solution that we need. So I started taking, at that point, a lot of the work I had done in kind of the side chain on top of Ethereum and started porting those concepts to Bitcoin. And I started building out a full, I guess I'll call it a token language or really a state machine that isn't just concerned about the state of Bitcoin UTXOs themselves, but other things that can be contained within those UTXOs and what that means for how we can interpret those things to mean other things than just these Satoshis were sent from this address to this address, but a far more full solution. Now, at that time, we're also building lots of other infrastructure pieces to support this. We're doing tons of R&D. And so I believe it was about March or April of 2018, I'm sorry, 2019, that Brenton Gunning from Run approached me and kind of shared with me what they had been building in Run.